Before I start talking about the topic, Larry or Sabla, remind you, are there any other announcements for CPS or anything that should be covered?
I don't have anything.
Just that we're happy everybody's joining us for the CPS core conversations.
So can everyone see the slides? Biostatistics trends, pilot studies. So this is the CPS conversation hour. So what I'm presenting is, I think it's about 10 or 12 slides. So it's roughly about, I don't know, probably 30 minutes of talking or something like that, maybe a little longer. So I didn't want to make it, entirely a presentation or a tutorial, but rather something where people could interrupt and ask questions and even express opinions that might be different than what I'm presenting here. So in statistics, I tell people this a lot because they often don't realize that statistics, in my view, is actually very much an art form. There's very solid information. It's a very solid base in mathematics, but once you leave the math, how you actually use it to best advance science, is always something that's not, part of a formula, right? So, so what I'll be talking about today are, sort of certain things that I call best practices, but I put that in quotes because it's really, there is no official best practices, manual in biostatistics. There are articles that sometimes use that title, but to some extent it's necessarily opinion based, and so this is going to be biased, of course, by my own opinions based on the work that I've done in statistics, but and what's considered best does change over time, and I myself occasionally do change my mind about different approaches, which makes it an interesting field for me. So there was, let's see, I think at least one question that came in sort of during the registration part, and I believe the question was very general, something like, how should statistics sections be, presented in a grant application? So very general. So I've decided here to just have sort of a few tips on doing that, which I'll go over in a minute. And that would be something if other people have other tips or questions about it, it's worth discussing. Grant applications, of course, are they're judged at the NIH by different review sections or by private foundations, and from the feedback that I've seen, and probably dozens, if not hundreds, of grant applications over the years, is that that study sections really do differ from one another in terms of how they approach certain statistical issues, and lots of times there are inconsistencies in reviews. So it makes it difficult to sort of give a very general set of advice on how to do this, but I'll try to do some of that in a minute. The bulk of what I'll be talking about today is kind of a mini tutorial on pilot studies from the partially from the biostatistics point of view, partially just sort of a general review of what pilot studies are and what they're meant to produce. So I wanted to focus particularly on pilot studies because most of the consultations that I provide through the CFAR are for pilot studies or for other small studies, and they're often, they're often involved difficult issues in statistics, not necessarily complicated, but difficult in some way. There are lots of other topics that one could, or I could talk about concerning kind of best practices and changes in statistics and how things are perceived by statisticians. So I've listed a few here. These are things that I wasn't really planning to talk about, except for maybe one little slide on p-values. But if people have questions about that, please let me know, put it in the chat box. And if we have time, I'll go over it. So just really quickly that, I sort of try to be a little bit cute here about our p-values going out of fashion. There is a controversy that's been brewing about significance testing and p-values. The controversy started first p-value, maybe 100 years ago, but it's sort of gained a lot of momentum within the last few years, particularly in the behavioral and social sciences, but to some extent, certain areas of health research as well. That our p-values really causing us more trouble than they're worth in terms of advancing good science. So it's an area of great controversy and no real clear-cut answers, although there are some advice I suppose I could provide about that from my perspective later. Another area sort of to think about is programming. So, if you're programming in SAS or SPSS or something like that, there is a little bit of a trend, and still a very small trend, but moving in a certain direction of increasing towards the expectation that studies that are published in the better journals will have their actual programming code available to be sent in and reviewed by journal reviewers, editors, or maybe even published online. Now, I personally have not been involved in a study that's required that, but I have seen instances where it may be required. So that's sort of another area where I'm mentioning it to you because it's something that you need to pay attention to, and it can be a little bit scary if your program code is, whether it's done by you or research assistant is kind of a big mess, which sometimes it is, and I'm guilty of that myself. Next is sort of multiple significance tests and the problems that they cause. It's a very difficult area. Missing data, if it occurs at a rate that's causing you to lose more than 10 or 15 or 20% of your data for an analysis, that's a complex area and sometimes needs to be addressed. And the other sort of trend in the field is, again, this is coming a bit more from the social and behavioral sciences, is for pre-registering your study in order to get it published. So clinical trials are always pre-registered. They're always posted on, like on a government website or somewhere else. But here I'm talking about studies that are observational studies. They're not clinical trials, which traditionally have not been pre-registered. So there's a little bit of trend going on towards an expectation for that. That trend, by the way, is not occurring for pilot studies. I don't think that there's, I may be wrong, but I'm not aware of any requests that pilot studies be pre-registered. So, let's see, before I get into these tips, does anyone have any comments? This point? Okay. So, so here are some, and also since my voice is fading in and out a little bit, if you can't hear me, someone please speak up and let me know. So tips for grant applications. The first three here are kind of different sides of the same coin, which is that if you have a non-trivial statistical analysis section in the grant application, application. It's not a really super simple one. For example, one where you're trying to control for potential confounding variables, let's say. Really try and use that section to help the reader understand, the story of what you're doing and why you're doing it, what you specifically expect to find. And that may seem obvious to you, but I've seen many stat analysis sections, including those written by experienced statisticians, that don't tell a story. They're just sort of almost like a long list of technical, things that will be done. We're going to do this, 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 and you don't really get a flavor. You really don't understand, well, why are they, using one particular method? What will that tell them? What will you actually learn in the end from the study? Will it be, whether there's, a correlation between X and Y after controlling for some other variable, or is it something else? So remember, in the grant application, you don't have much space, and you want to use it well, and you want the reviewers to read it, not just sort of skip over it. Don't go overboard with technical statistical jargon. I've seen this. This is often sometimes done by statisticians, where they get into just too much jargon, and you don't really understand why they're talking about it. It just seems very unnecessary. And at the other end, sometimes people include a lot of really simple stuff, and they'll waste, in my view, 3 paragraphs talking about how they're going to look at the distribution of each variable, and we're going to test for outliers and test for normality, and this and that. That may be fine for a PhD dissertation, but it's not fine when you really don't have much space and you have to explain things succinctly. And sometimes I've seen, actually more often than I've seen cases where people have included what I call boilerplate sections that don't really apply to the current study. So they'll be talking about the distributions of the variables when the only variables of interest in the study are categories, for example. It just doesn't make any sense to do that. So now those studies, oftentimes studies will get funded, right? Even though the stats section isn't very good, and we're experienced people getting grants. Sometimes that's kind of a bad lesson, because they've just learned that what we need to do is copy and paste from another grant, and it'll work just fine. That may work for a while, but that's really not the best approach. So, and then finally, oftentimes you have to make a choice between analysis methods where, you're not really sure. There's controversy as to what approach should be taken. Should you, do a, control for differences between 2 groups using both linear regression as well as propensity score matching, for example, where some people would say, well, you don't really need the propensity score matching, just use a standard regression approach, or vice versa. So, my advice there is, or you're using maybe some really fancy approach, some Bayesian approach, take the time to explain why you're using one approach over another. Usually the reviewers, I think, appreciate that. It helps guide them, and especially if you have relevant references that, that just makes things, it gives the reviewers a little more confidence that, that you haven't just arbitrarily picked something out of the blue to include there. So the next part of my discussion will be on pilot studies. So before I do that, regardless of whether you're kind of new to grant writing, never done it before, done it a little bit, or highly experienced, does anyone have any comments or other tips in terms of biostatistics sections or, you know, reviewers' comments that you've received on grant applications regarding statistics that have kind of left you baffled about, you know, should I be doing something differently? Well, if anyone thinks of anything later,
I have a comment or
right?
question. I don't know. So one piece of the statistical analysis set is the power analysis.
Mm-hmm.
And so what are some of your basic tips, like with this, for that particular section?
So I do, you know, I do tend to do a lot of consultations on power analysis for grant applications. It's probably the most common request that I get. So I think, first of all, some studies don't need a power analysis, formal power analysis calculation per se. And I'll be talking about that a bit when I talk about pilot studies. But even certain confirmatory studies or sort of full-blown studies don't necessarily need a power calculation. Obviously, if a study is qualitative, you know, it's all qualitative interviews, then statistics are irrelevant anyway. But you know, there are a lot of studies that are done that are meant to produce good statistical estimates. You know, what proportion, what proportion of people living with HIV in a particular setting have you know, a certain kind of malignancy or something at a certain age or something like that. You know, there are lots of questions like that. So those aren't answered with a power calculation. They're answered typically with a sample, with a confidence interval on the estimates. So I'll show you that for pilot studies in a few minutes. I find for power calculations, keep in mind that there are kind of two approaches to estimating them. One is based on an effect size that has been observed in other similar studies. So you might say, well, you know, let's say you're doing a study of whether a particular intervention increases the, you know, adherence to PrEP or something like that. If it, so maybe you know that there have been similar studies that have looked at other methods, and they typically find that the very best studies produce a 25% increase in PrEP uptake among certain population that you know is reluctant to use PrEP. So that could be the basis for the power calculation. But another study, another approach would say, well, what we're really interested in is the minimum uptake, you know, increase in uptake in PrEP that would be considered clinically important or important for policy purposes. And there, you know, maybe you could argue that, well, you know, even a smaller uptake, if we can increase uptake in this population from 20% to, you know, 30%, that would be great. So just be aware that those are different approaches. Usually they're kind of blurred, and I myself sometimes when I wrote a power calculation, I won't really make a clear distinction between those two approaches. In terms of how the power calculation might influence the reviewer's judgment of the grant application, basically, you know, I think the general rule is that the more uh, expensive the study, the bigger the study, the greater the risk to participants, the more effort should go into the power calculation. So, so for small studies with where the risk is to participants is minimal, personally, I don't think that a very elaborate power calculation is needs to be done. You need to do something, but a more elaborate one would spend probably a lot more time thinking through and checking the literature for related studies for estimates of, say, standard deviations of outcomes, because you need a standard deviation, say, for a continuous variable to do a power calculation, or an estimate of effect size. So for the biggest, most risky studies, the statistician could easily spend 2 weeks with the investigator, reading through dozens of papers that are to really come up with the best estimates possible for doing those calculations. Does that answer your question?
Yeah, thank you very much.
Okay. All right. So it's not labeled, but this is the first slide talking about pilot studies. So in this slide, I actually don't even call them pilot studies, and that's because the definition of pilot study does vary. So I just call it here a pre-study. So this is just a very simple way of thinking about it, which is we're talking about a study that's really what I think of as a pre-study. It's not a study designed to directly answer a scientific question of interest. It's designed to provide information so that you and grant reviewers and anyone else interested has a lot of confidence in designing and conducting the main scientific study. So, I think in the ideal world, in terms of grant funding mechanisms and things like that, there probably would be multiple stages of pre-studies where maybe you try it out once and you see, oh, well, this didn't work and that didn't work and that didn't work. Let me change it and then do another one, repeat it again, and see if that fixes it. And it's only when you've got to the point where you've fixed all the things that you think could go wrong that you're really ready to apply for the main scientific study. So that's kind of my view of it. So here are just some definitions in the first set of bullets. So a very broad definition of a pilot study, this is just my own definition, it's really any lower budget study needed before you do a larger study. So so funding agencies, organizations like the DC Center for AIDS Research, and lots of others typically will use the term pilot study with this meaning. In other words, they're not necessarily funding. There are some studies that get funded that aren't technically pilot studies by certain other definitions. But a more typical pilot study is really designed to assess feasibility and acceptability. And I'll mention another term that I myself have been a little bit sloppy with in the past, which is a pilot trial. So pilot trial is really meant to be a very specific kind of pilot study designed typically for randomized clinical trials, where it's essentially, I think of it as being a dress rehearsal of the full study. And the only difference is that you're using a small sample size. So in other words, the pilot trial would be one where you're not worried about it. You're really pretty confident at this point everything's going to work okay, but you're not quite ready to where the NIH is not quite ready to spend that $5 or $10 or $20 million for the main study main trial, because, they just, you just want to make sure all the pieces really do fit. Um, and I don't have it here, but there's an article, you might need to remind me later, that I came across that talks about reporting standards for pilot trials. So again, it's this more narrow focus, but a lot of the recommendations in there, actually, I think you would find very, very helpful for other pilot studies that aren't technically pilot trials. See if I can pick that up later. I think it's a really good reference. Covers a little bit of some of the material I'm talking about in this tutorial. So, personally, I like, I think it's always a good idea when you're to not think about, well, I'm going to apply for this pilot study, to just focus on a pilot study. You really should have in your mind the scientific study that would come later, because if you focus too much just on the pilot part of it, I don't know, you can lose track of what really you're planning to do in the main study. And by that I mean that you have to think through, you should think through all the details of that main scientific study. That's the next step, and think about all those things that could go wrong. And I'll give you a list that I put together on the next page that most of you probably already know about. So, so the kinds of information that you need before those large R01s or other expensive trials would be, what can cause the main trial to fail? How can I prevent it? The second thing is the part that people like me really like, which is estimates of variability that we need to do the power calculation for the main trial. So again, if the outcome is a continuous variable, we need, let's say it's, a CD4 count or something like that. We would need some estimate of that standard deviation in this population to come up with a reasonable power calculation. Or if it's the outcome is a binary proportion, we would need an estimate of what proportion of people go on to have a malignancy or something like that could have been prevented. So the third kind of information, and this is kind of the trickiest one, is is there, from a pilot studies, you'd like to know, is there support for my hypotheses that you can present as preliminary data in the grant application? So this is something that, of necessity, you need to do out of your pilot study if you're applying for an NIH grant. Certainly if it's an R01 and certain other grant mechanisms, it's unlikely that you'll get funded unless you present some preliminary data. On the other hand, the really tricky thing is that you usually don't have enough data in your pilot study for that preliminary data to be terribly reliable, and usually you don't have good statistical power. That being said, presenting some estimates of what you're getting, is better than nothing, and that's sort of the logic that you'll need to follow if you hope to get an R01. So, here's sort of a detailed list of things that some is from the literature that I saw, some are things that I just observed. There are probably others as well. I kind of group them into feasibility and acceptability items versus other kinds of information that a pilot study can help us with. The bullets that are highlighted in turquoise are can be quantitative. In other words, they can be actual numbers. Well, we found an average of 6 people per month were available to be recruited, and so forth. 22% were highly adherent, and 80% were partially adherent, something like that. So when you're designing, if you have a pilot study that you're designing for quantitative, for a confirmatory study, and these are relevant statistics, then you should plan on gathering as many of them as you can in your pilot study. And because they all will be important for deciding whether you can go ahead with the full study or not, whether you're ready or not. And you'll see there are lots of things that aren't highlighted, and those are qualitative issues. And over the years, I've seen problems with every in full funded R01s. I've seen problems with every single one of these items, and I think most experienced statisticians, biostatisticians, will tell you that never trust it when an investigator tells you that they can easily recruit 20 patients per month to be in the study, and that they'll stay in the study. I know occasionally it's true. Occasionally it really their estimates are just right, but I think it's just sort of a natural human tendency to be overconfident, and that's one reason to do these pilot studies, so you can really see for sure. So again, those feasibility and acceptability items, if any one of them fails, then something has to give. Either you have to change your study design, or in the worst case, give up on that whole study. As an aside on that, I'm not a big fan of people giving up on studies. I think that the key there is, think about the significance section of a grant application. If you can make a really, really strong case in a significance section that your study is important and should be done, and that you simply have to overcome certain logistic problems, then in terms of recruitment and so forth, and you think you can do that, then you should persist until you get all these things working correctly. Anyway, that's just a little side commentary. So so there are other very qualitative things that are really important, I think, in a pilot study: staff training, team science experience, logistics. So I'm talking to you both as people who may be applying or have applied for pilot studies, but also as people who serve as reviewers, either on NIH study sections or other grants, review committees. This is, again, my own view is that for a lot of studies, simply having the investigator getting experience with the team, with the training, with the sites, with the administrative issues that may come up, that in and of itself is often extremely valuable, and many studies should be funded. Pilot studies should be funded on that basis alone, even if they're not collecting a lot of data from participants. Anyway, that's just my editorial. So other things, scale, measurement, reliability, validity. Sometimes you have enough data in a pilot study to assess that, sometimes not. If you're it's not listed here, but if you're translating your measure, into two languages, English and Spanish or something like that, it's an opportunity to see how that went in terms of not so much quantitative, it's more qualitative issue. And then statistics that you'll need for the later power analysis. So those statistics will depend on the specific kinds of analyses that you're planning for your main study. again, typically it's the estimates of variance. Sometimes you need to know the distributions, proportions, so having a particular outcome, proportions in a particular risk group, if that's the purpose of the study. If it's a study involving outcome events, how often someone, winds up going to an emergency room for care. You want to get, look at the distribution of that. Is that seem to be following a Poisson distribution or something like that? For repeated measure studies or sometimes an analysis of covariance, having a good estimate of the correlation between the baseline measure and the outcome follow-up measure can be extremely valuable for the power calculation. And then the part in yellow, which is the tricky part, is the significance test and estimating magnitudes effects. So let me talk. I'll go back to that in a minute. So sample sizes for feasibility statistics. So if you're estimating things like proportions, typically we handle that in a pilot study by estimating the confidence interval for the proportion, for example. So here's an example here where supposing you're expecting, based on your experience, what other people tell you, that 70% of your sample who you recruit will still be in the study at the 3-month follow-up. And you're also making an assumption that, if more than 50% of the participants are lost to follow-up, that would be a disaster, right? So, so you might want to do some calculations that, well, supposing you had a pilot study with only 10 people, well, so in this example, if you had 7 out of 10 who were retained in the study, the confidence interval would be 0.40 to 0.89. If you upped it to 30, and you had 21 out of 30 retained in the study, then the confidence interval gets more narrow and it's 52 to 83. So, so you could use that loosely to say, well, okay, 10 is probably not enough to give me a good estimate, or a useful estimate of study retention. But, if I can get it up to 30 people, it's not too bad. And it'd be nice to have it a little bit more precise, but, we can live with that. Keeping in mind, and this is not a bullet point, that in many studies, including pilot studies, there's a practical limitation on the sample size, either because the population that you're interested in is just, it's limited in terms of the number of people who would potentially be available within the time frame that you have, or for reasons of money. If you're doing an expensive study per person, you may not be able to afford more than 10 or 20 people in the study. So, if you've ever worked with me, on a consultation for a pilot study, I sometimes will say, well, let's just work backwards. What's the largest sample size that you could, manage, that you think is realistic, and then do the calculations like this and say, well, okay, is that going to give you enough precision to be useful? So let's see. Let me just have a few more slides. This is very subjective. When I say it's a disaster of less than 50% were retained in the study, but it is worth thinking about, even though the number itself is going to be kind of arbitrary. It's probably, if you lost 5%, very few studies would consider that to be a disaster. If you lost 90%, almost anyone would say that's a disaster. So it's good to think about those things. And to be realistic about what it would mean for the ultimate scientific integrity of the main study if you had, a really, really poor recruitment rate or retention rate or something like that, or adherence or acceptability. One system that I sometimes recommend people, it's more typically recommended for pilot trials, is a traffic light system of benchmarks. Some statisticians recommend this. I think it's useful. I wouldn't take it too seriously, the actual percentages, but it's a way of sort of conveying to the grant reviewers that you understand that some things may not turn out the way you'd like to, and you'll actually be using this data from the pilot study to make some decisions about whether parts of the trial design need to be changed, such as typically it's recruitment and providing more of an incentive to get people into the study, or changing your inclusion criteria to make it looser. So some use this sort of green, yellow, red, where red is something where it's it's complete disaster. It's sort of hopeless, and I hate to say hopelessness. It's usually you can think of some way of possibly saving the study. So sample sizes for power calculations. So again, typically we need an estimate of the standard deviation or proportion. But we need to then think about, well, to estimate a standard deviation, let's say you did a pilot study said, I'm just going to do 3 people. Well, your estimate of the standard deviation is going to be really, really lousy, right, in that case. And sometimes people are forced to use standard deviation of 3. That's typically for studies with animals where you just can't get more than 3, or it's too expensive to do the assays. But so at some point, the estimate of the standard deviation becomes a little bit more reliable and useful. So I'm not going to give you, I don't have an actual answer for you here as to what sample size you would need to have these estimates. It really depends a lot on the specifics of the study design. There are some formulas and guidelines. Generally, statisticians, well, we're not always happy about it, but if you do a pilot study and have an estimate of the standard deviation, we'll take that, and it's better than nothing. But we'll often, instead of using the actual estimate of the standard deviation, we'll inflate it a bit, assuming that the true standard deviation may be higher. And there are different approaches to doing that. So, are significance tests okay in pilot studies? So most pilot studies are not designed to have good power again. And there are some potential scary to a statistician risks when you have a small sample pilot study, and when you're doing significance tests. So one is sort of, I think everyone, probably most of you know already, which is if you have a non-significant result, there's a temptation to say, well, there was no effect there, or this, adherence has no effect on HIV viral load or something like that, when that's an incorrect conclusion. There are a couple of other mistakes that are much less known. Even most statisticians don't really know about them, but one is called a sign error, where you get a significant result, which can happen by chance. A chance result, in some circumstances, is actually a surprisingly high probability that the result will be in the wrong direction. Now that doesn't happen that often, but it is a worry. In other words, your intervention that you thought would really help things out is statistically significant, but it's showing that the intervention is making things worse. That's really bad error, right? And the other kind of error, which is related, is when you get those significant results on a small study, a magnitude error can occur, which is where the average estimate for the significant results is way above sort of what it really truly is. And that would be I don't have time to really explain that well, but I'll just review it quickly here. So these problems occur, excuse me, when the effect size and sample size are small and there's high variability or measurement error in the outcomes. So that is true of a lot of, unfortunately, it's true of a lot of studies, pilot studies that we do in CFAR, not true of all of them. So an example would be testing an intervention. Intervention increases the percentage of those living with HIV who are virally suppressed. The intervention, has a small effect. It increases the viral suppression rate from 75% to 80%, which from a public health point of view is good, but it's still statistically it's still relatively small. And if you're doing a small pilot study, I did some calculations. If you found a significant result, there's a 14% chance that the direction is wrong, and that the type M ratio is 6.2, meaning that on average, that result could be, it would be about 6 times larger than the true effect. So you may actually wind up with a conclusion that it could be in the right direction, but still vastly, overestimating the effect. So this is basically the last slide. Where most pilot studies with small sample size emphasize descriptive statistics, confidence intervals for reporting results. And it's if you can avoid it, try to avoid presenting the results of significance tests. But if sometimes it's still reasonable to report significance tests as sort of, it's just sort of an indication that, maybe there are certain signals in the data. If you do that, just be, really do need to emphasize the limitation on that. Because if you don't, people will take it as much more reliable than it truly is. And again, that's always the difficulty, the thing to worry about. So with larger sample sizes or tightly controlled experiments with low variability, then significance tests, I think, are a reasonable option. Some authors are really pretty firm, though, saying, well, if you're doing a pilot study, you should never report significance tests. My own view is a little bit more relaxed than that. Anyway, the last slide is on p-values, but it's almost 6 o'clock. So, comments, questions for the last 5 minutes. So, let's see. I'm going to close the screen sharing and see if I can dig up the reference and put it in the chat box that I mentioned. Give me 30 seconds. So the reference is it's an extension to the consort statement. So for those of you who have been involved in the clinical trials world, the consort statement is like the very first reporting guideline for studies. That it's a checklist that is designed to help authors and reviewers make sure all the key issues are covered. So this is an extension to that from a few years ago. Oops. So right now. Should have it. So so again, this is in some ways maybe the closest thing that we have to a formal written best practice on pilot studies. There are some other articles, and there's actually a journal devoted to pilot studies I saw recently. So there may be newer things, but that's basically it.
Sam, thank you so much. That was really enlightening, great talk, and such good tips. And I wish I had you by my side when I write my grant. Because for a lot of us, this the statistics part is really where we are, you know, probably the least comfortable for most of us. And these are really helpful suggestions. Are there specific questions for Sam from anybody in the group? And we will make the recording available to everybody so that people will be able to refer to your talk. Of course, I know we will continue to have a lot of people looking to you for your guidance. I have to say, there are times when I haven't thought to ask for a consultation for small studies, for the pilot studies, but I think that you had really good suggestions there too, how to make it very clear that it's not an oversight on your part when you're submitting a grant, where you're not glib about just saying, oh, we don't provide one because it's a pilot study, but to have some kind of nuanced discussion of how the information that you are getting will be helpful. I think that's really very helpful, actually, a great suggestion.
Yeah, I don't think it's a terrible thing for people to say simply it's a pilot study and we don't need to do a statistical analysis. But I think again, I think from some of the reading among the statisticians, I think they do make an argument that having a more formal discussion of these things, is better. Again, I don't think they're absolutely essential. No. Nina, you made a comment about the slides and the one on feasibility and acceptability. So yeah, I think I had considered a few years ago making that into like a little document to share, like a checklist. I like checklists because they just remind me of those things that I always forget.
Yeah.
So yeah,
That was very helpful.
Yeah, that was really great.
Thank you. And Larry, I'll send you the slides if you want to distribute them.
Thank you.
Okay.
Great. So if no other questions for Sam, we can go ahead and wrap up just on time. Thank you guys all for joining. And Sam, thank you so much for a great talk. And Larry will distribute. I think there may be some folks who weren't able to join, so we'll distribute it to everybody who had signed up to attend and who may not have been able to come today.
All right. Good to see you
Okay,
all.